Hi dear students, welcome back all of you to the physics online class. Today we will learn about the first phenomenon of the wave optics, that is the interference of the light. Before going to study the interference of the light, we should discuss about the Doppler effect and the superposition principle. Then first, in the first PUC you studied about what is the Doppler effect. Actually in that Doppler effect we discussed about the motion of either the observer or the source of the sound. When the source of the sound is near to an observer, for example the vehicle 108 vehicle, if it comes, or an ambulance if it is coming nearer to an observer, you know that the sound of that, the frequency of the sound is increased and the wavelength is decreased. If the same ambulance will move away from an observer, then the wavelength increases, frequency decreases. So such a phenomenon, when what happens during that condition, the observer may feel the change in the position, that is the apparent change in the frequency of the sound heard by an observer will change. So that phenomenon we called as the Doppler effect of the sound. But today we are learning Doppler effect of the light. Here also we take one observer and there is one source of the light. If the source of the light is taken away from an observer, you know that the wavelength of the light rays which are reaching the observer is increased. For example, a bulb, if the bulb is taken from, assume me only the observer, if a bulb is taken away from me, then what happened there? The wave, the bulb is a source of the light, the wavefronts are coming from the bulb and that wavefronts are reaching to me, isn't it? And when the bulb is taken away from me, the wavefront need to travel a longer distance to reach me. That means me means an observer, right? So if then during that time what happens? If the wavelength increases, the frequency of the light wave decreases, isn't it? So similarly, if the bulb is taken nearer to me, then here the frequency increases, wavelength decreases. So this effect of the light waves we call as the Doppler effect of the light. That means the apparent increase or decrease in the frequency or the wavelength of the light waves, either source of light moving or an observer is moving. When there is a relative motion between an observer or the source of the light, relative motion between observer or the source of the light, the decrease in the wavelength or increase in the frequency of the light waves reaching an observer is called as the Doppler effect of the light. Yes, and in the Doppler effect, the two terms we need to understand. The first one is the red shift. Red shift. What is the meaning of the red shift? That means if the object, the source of an light is taken away from the observer, the secondary waves reaching the observer will take the longer distance. The wavelength increases, frequency decreases. Such a shift is called as the red shift. How to keep that in the mind? Red means that color having the longer wavelength. Therefore, here what happens? The wavelength of the light reaching the observer increases and the frequency decreases. Such a shift we call as the red shift, right? Then second one is the blue shift. Blue color means it is having a shorter focal length. Shorter focal length means, wavelength. If wavelength is a shorter, distance is a shorter. Distance is a shorter, frequency is a longer. So that means a high frequency will be there. So in a blue shift, the light waves coming from the source of an object or the light it is reaching an observer, the distance is decreased, right. The decrease in the distance or the wavelength of the light reaching an observer is called as the blue shift. So, one is a red that having the longer wavelength, another one is a blue shift that is having a shorter wavelength. Okay. Then the change, the apparent change in the frequency of the light rays reaching an observer can be given by a formula called as delta nu upon nu is equal to minus VR upon C. This is the Doppler formula for explaining the Doppler effect in the case of the light waves, right. So, here delta V means that is change in the frequency with respect to original is equal to minus VR by C. What is the VR here? VR is called the radial velocity of the source of the light, and C means it is the speed of the light in the vacuum, and we know that C is equal to, we can give that as a frequency into lambda. Then by using this, again the formula can be converted as delta nu by nu is equal to minus delta lambda by lambda. Like this also we can express. So, this is the expression for the Doppler effect of the light. So, VR means what? The radial velocity. If two or more celestial bodies are moving with respect or relative to each other, the velocity that we call as the radial velocity between them, the velocity is the radial or the relative, and here the C is taken as the velocity of the light in the vacuum, you know its value. Yes, and the same formula I can express in terms of the change in the wavelength with the original wavelength also. I hope you understood this concept. And moving to the next one, in order to understand the interference of the light, we must learn what is the superposition principle. Yes, this principle also we discussed in your first PUC physics, that is while studying the concept of waves. Waves ಅನ್ನು ಸ್ಟಡಿ ಮಾಡಬೇಕಾದ್ರೆ ಇದನ್ನು ಕೂಡ ಅಲ್ಲಿ ಹೇಳಿದ್ದೀವಿ. Yes, what is the superposition principle? Assume there are two or more waves. I can represent them here. So, this is a one wave and this is a second wave. Maybe two or more waves are present and that waves are superposing, that means overlapping each other at a given point, at a given instant. You want to calculate what is the total displacement of the wave at a given instant and at a given point. Then the total displacement traveled by the wave at a given instant can be given as vector sum of the individual displacements. Y1 means the first wave displacement, Y2 for the second, Y3 for the third wave. Like this, how many waves are superposed each other, you can take the displacement of that waves and the vector sum of the displacement of each wave in the group or in the superposition, that gives total displacement of the wave at that given point. Yes, so this we called as the superposition principle. What is the statement of superposition principle? It states that the total or the resultant displacement of the wave at a given point is equal to the sum, which is some vector sum of the displacements of the each wave at that point at a given instant only. So, I consider here y is the resultant displacement, y1, y2, y3 are the displacement of the respective wave. If only 3 are there, we are taking only up to y3. If n number are there, I can continue that up to the yn. Am I right? So, then remember which principle is very important to study the interference? The superposition principle of the, so light waves are very important to understand the interference of the light, right? Yes, then let us talk about the interference of the light. What is the interference? It is the first phenomena related to the wave nature of the light. Interference means, actually here we just came to know that during the superposition of the principle, there is a chance for two or more light waves, they can superimpose each other. Sometime crust may fall on the crust, or crust may fall on the trough, or trough may fall on the trough. So in such a condition, what happens? There the redistribution of the intensity of the light is taking place. The redistribution of the intensity of the light, when two or more light waves will superimpose each other in the same direction, that phenomenon only called as the interference of the light. Yes, what is the interference of the light? Interference of the light means when two or more light waves, of same frequency and same velocity superimpose each other in the same direction, redistribution in the intensity of the light is called the interference of the light. Or you can simplify the definition with another sentence: the modification in the intensity of the light. Modification means what? Changing. There at some point there may be a small intensity, at some point there may be increased in the intensity. Yes, the modification in the intensity of the light when two or more light waves of same frequency and the same wavelength superimpose each other in the same direction. So that is called interference of the light. Then what are the phenomena, what are the illustrations or the examples which we can observe in our surrounding by the interference of the light? Where the interference of the light taking place? The good example is, first one is the oil spilled over the surface of the water shows the thin color films. Why it is? Because the interference of the light. Oil ನೋಡಿರಬಹುದು, ನೀರಿನ ಮೇಲೆ ಒಂದು ಯಾವುದಾದ್ರೂ ಎಣ್ಣೆ ಹನಿ ಬಿತ್ತಪ್ಪ ಅಂದರೆ ಕಲರ್ ಫಿಲ್ಮ್ಸ್ ಫಾರ್ಮ್ ಆಗ್ತದೆ ನೋಡಿ. ದಟ್ ಈಸ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ದ ಇಂಟರ್ಫರೆನ್ಸ್ ಆಫ್ ದಿ ಲೈಟ್. And the second one, have you seen the peacock feathers? There also when the peacock feathers will spread, there is a shining face of that feather. That is because of the color changes, the modification in the color is taking place. That is also because of the interference of the light. And if you come with the experiments, there also in our laboratory, the formation of the Newton rings taking place. There alternative bright and the dark rings will be formed. The formation of the Newton rings also, it is because of the interference of the light. Like this, the interference of the light we are observing in some of our day-to-day life examples. I hope you understood what is the interference. Then in order to study the interference of the light, we need to know how the waves are going to be superimposed. Actually here the waves are superimposed. For that particularly we need a particular sources. In order to get the interference of the light, we need a particular sources. That sources are called as the coherent sources. Co means the same, herent means they are emitting the continuously same phase, so that waves. Coherent sources are what? The any source of the light. Coherent sources means what? Any source of the light continuously emitting light waves of same phase or zero phase difference. See here, Coherent sources are what? These are any sources of the light continuously emitting light waves of same phase or zero phase difference. If they are emitting same phase, for example, from the coherent source, example I can take here, example, the light waves which are coming from the bulb, that two separate, they act like a coherent sources. Two light waves which are acting, that means for example, if it is a source, the bulb, let us consider here. From the bulb, here also one wave come, here also one wave, and when you take that wave through the through the split into the, so that light wave into two, that might be by two, so different divisions are there. I will explain you. To the single light wave that splits into two from the same source can act like a coherent source. Okay. So, coherent means what? These are continuously emitting the light rays of the same phase or zero phase difference. Remember this point, the coherent sources have a same phase or zero phase difference. Phase difference should be zero or both will be having the same phase only. Yes. Then the light which are coming out of the coherent sources can be divided in two methods. They can be taken in two methods. One is by the division of the wavefront. So, what happens in the division of wavefront? Assume here is a plane wavefront, and what is the wavefront? Everything we discussed already in the previous videos, right? And this is a plane wavefront, means every point on the plane wavefront act like a source for the secondary waves. That Huygens principle that we explained and studied in the previous videos. And if you want to get the interference of the light, we need to divide this wavefront. We have to divide. So, the coherent sources and the interference of the light can be obtained by either by division of the wavefront or by division of the amplitude. Sometime we can divide the amplitude also. What is the amplitude? If one wave I consider like this, and this is a complete, the maximum distance travelled by the particle only called as the amplitude, and here we can divide the amplitude. So, either by the division of wavefront or by the division of the amplitude, the interference of the light is taking place. I hope you are understanding the point, right? So, then let us move to the next point. What are the types of the interference? See dear students, you studied that interference means what? It is the phenomenon of modification in the intensity of the light when two or more light waves of same wavelength and frequency superimpose in the same direction. Okay? Or you can also say that the redistribution in the intensity of the light when two or more light waves of the same frequency, same wavelength superimpose in the same direction, right. So, then here actually the interference of the light is classified into the two types. Mainly we are classifying them into the two types. The first one is the constructive interference. First one is the constructive interference, and the second one is the destructive interference. What is the second one? Destructive interference. Then come, let us discuss what is the meaning of the constructive interference. Constructive interference. Yes, during the construction what happens? Whether there is an increase in the building taking place or decrease in the building. So, definitely there is an increase. Here also same thing. If you are talking about the constructive interference, here the intensity of the light goes on increasing. Then if the intensity of the light should be increased, what should happen there? There in the constructive interference, what happens actually when the constructive interference is taking place? Assume it is the mean position, right, and here one light wave is moving, and see in the previous, that means in your first PUC you studied that this, if a wave is moving, that is a progressive wave, this part of the wave we call as the crust, and this is called as the trough, right, and this is the first wave. Assume there is another wave. When one wave, the crust of one wave fall on the crust of the another wave, or the trough of the one wave falls on the trough of the another wave, what happened here? According to the superposition principle, you know that here is the y1 distance and here is the y2 distance. At this point, if you want to find the resultant means the total displacement of the wave covered here, that is given by y is equal to y1 plus y2, isn't it? Or if you want to take here also, there also you can get the same only, because so here what happened, the intensity of the light increases. Remember dear students, during the constructive interference, when a crust of one wave falls on the crust of another, or trough of one wave falls on the trough of another, their intensity of the light wave increases, and by the superposition principle, the resultant displacement can be given as y is equal to y1 plus y2. Yes, here plus we are getting means definitely what happened here, the intensity is increased. Such a interference is called as constructive interference. So, such a type of interference is called as the constructive interference. What is the constructive? The interference of the light in which when a crust of one wave falls on crust of another, or trough of one falls on the trough of another, during that there is increase in the intensity of the light. So, the interference is called as the constructive interference. I hope you understood this point. Yes. So, then next one is the destructive interference. Destructive. Destruct means what? There should be decrease in the destructive, decrease, constructive, increase, right. So, in the destructive interference of the light, so same thing here also, but in the destructive what happens, the crust of one wave fall on the trough of the another wave. You can see here, if here y1 is the displacement of the first wave and here y2 is the displacement of the second wave, and in this condition y1 means it is above the axis, so I can take that as a positive, and here y2 means it is below, that I can consider as a minus. So, if you want what is the total displacement covered at this given point by the superposition principle, how can you take this formula? That y is equal to y1 minus y2, this will be the resultant displacement at a given point in the destructive interference. That means in this condition there is a possibility of the decrease in the intensity of the light when a crust of one wave falls on the trough of the another wave. Yes, and this type of the interference of the light is called as the destructive interference. I hope you are understanding the point. Okay, see dear student, in the interference, as I told you earlier also, the chapter in this mainly we are dealing with the two phenomena. So, one is the interference of the light and the second one is the diffraction of the light. And we started today with the concept of the Doppler effect, that we need to study if the source of the light is moving nearer or away from the observer, how the wavelength or the frequency is going to be changed. Yes, and that is given by the formula. The apparent change in the frequency of the light wave can be given by that formula. Then next we need to understand the superposition principle, because remember which principle is involved in the interference of the light means your answer should be superposition principle. Then you need the statement. The superposition principle states that the resultant displacement of two or more waves at a given instant is equal to the vector sum of their individual displacement at that point at that instant only. So, by the superposition principle, the resultant displacement y is equal to y1 plus or minus. Why I have taken plus or minus? I used the term vector. Vector means it may be plus sometime, it may be negative, that means minus also. So, we use it here. Then this principle only involved in the interference. Then interference means, keep it in your mind, modification in the intensity of the light. That means when a light waves are moving, when two or more light waves are superimposing or they are overlapping each other, at some points you observe that there is increase in the intensity and some point decrease in the intensity. Like this modification of the intensity of the light is observing, that only called as the interference of the light. Okay, and this interference of the light, if you want to take place, remember what type of the sources are required? Coherent sources are required. And one more question may come, how many coherent sources are required for the interference of the light? How many coherent sources? Remember dear students, minimum 2 coherent sources are required to form the interference fringes. Okay, then the interference of the light can be taken place with the help of either division of the wavefront of light or by the division of the amplitude, and you know already how that is divided. And next, according to the increase in the intensity or decrease in the intensity, the interference of the light is classified into the two types. Yes, the first one is the constructive interference and the second one is the destructive interference. In the constructive, we came to know that when a crest of the one falls on the crest of the another wave, or a trough of one falls on trough of another, there is increase in the intensity of the light. So, that type of the interference we call it as the constructive interference, right? And later, with the help of the superimposition principle, we also used the formula y is equal to y1 plus y2 for the constructive. Yes, and next one is the destructive interference. Destructive means here the crest of one may fall on the trough of the another. During that, the vector sum of displacement we are considering, hence the intensity of the light waves will decrease. So, such a interference of the light we call as the destructive interference. Okay, I hope you understood. And further, related to this, we need to understand the theory of the interference, and there one derivation is there for the 3 marks, and later we discuss the fringe width, the Young's double slit experiment will come. That is the very important 5 marks expression in this chapter. Okay, that further points we discuss in the next class. If any queries, you can ask me. Thank you for watching the video.